Alright, we're going to begin section 14.1 in this video, which is double integrals. Alright, so first, just to kind of orient ourselves. So in single variable calculus, we integrated functions of one variable over a one-dimensional region and interval of the form, so the closed interval from A to B. So we would just have, say for instance, in the xy plane, we have some function, some continuous function, f of x. And then what we do is we integrate that continuous function over some closed interval from A to B. So we were considering that function over this interval right here. So we'll say integrating f of x over the closed interval from A to B. So now I'm going to relate that to what we're going to do now with functions of two variables. So now the functions we integrate will be functions of two variables and the region over which we integrate will be a two-dimensional region. Which we'll call capital R in the XY plane. Oops. So I'll sketch a picture of this as well. And don't worry too much about the details of the picture, so your picture doesn't need to look exactly like mine. So now we're given some function f of xy, whatever, just sketch some surface up here. So this is f of xy. whatever, that's our little surface. So now what we're considering is we want to integrate this function over some region R in the XY plane. So let's just sketch some region R, and it doesn't have to like look identical to that, whatever, just sketch something down here. So say that's our region R. So now, so there's the function f of xy that relates to the function f that we had in the picture above. But what we're concerned about for the most part, I mean, we are concerned about that, but we're concerned about this region R in the xy plane, because that's what we're going to oftentimes have to figure out, and those are going to give us our bounds for our integral. So this region R down here, that's the region R, which would be in the xy plane. So this region kind of relates to the closed interval from A to B. The function f of xy relates to the function of f that we were doing and that we were using in calculus 1. So I sketched the surface and the region. We won't sketch the surface though. We will sketch the region. So in practice, we will always sketch and define our planar region capital R, the region over which we are integrating. We'll consider two types of such regions. First is type Roman numeral 1. And make sure you use Roman numerals because we're going to use Arabic numerals to label our regions when we get to triple integrals later. So we'll need to differentiate between the Roman numeral 1 and the Arabic numeral 1. So, and it's given by R equals the set of points x, y, such that x is between some constants a and b, and then y is between two functions, g1 of x and g2 of x. So when I say define our region, that's what we would write down. Now we actually have some numbers and some functions in here though. Now what does a type 1 region look like? So a type 1 region is going to be a region that looks exactly as described here. So you're going from function to function in the y direction. You can sketch whatever continuous function you want to up at the top and at the bottom. Now you need to have a vertical line though at the left and a vertical line at the right. So we're going, this would be over here on the left, that is x equals a. This is x equals b. And then this function down here at the bottom, that little curve down there, that would be g1 of x, and this curve up here at the top would be g sub 2 of x. And then I always sketch an arrow in our region and which direction we go from function to function, and we're always going to move in the positive direction. So we are going from function to function in this direction. So a type 1 region is where you're going from function to function in the positive y direction. And this is our region R. All right, so that's a type 1 region. And then the type 2 region. So let me just, some of those things I stated. So y goes from function to function and x goes from constant to constant. And then a type 2 region actually, let's double underline the type 1 and type 2 because that's going to be important. We're going to use those names quite a bit. So type 2, Roman numeral 2. So that will be a region of the form R equals the set of points x comma y such that y is between two constants c and d, and x is between two functions h sub 1 of y and h sub 2 of y. And we'll sketch a type 2 region. So here we're going to have some function of y at the left, some other function of y at the right, and then you're going to have a horizontal line at the top and a horizontal line at the bottom. This line at the top is the line y equals d. The line at the bottom is the line y equals c. Then this function on the left is the function h sub 1 of y. And the function on the right is h sub 2 of y. And we're going from function to function in the positive x direction. So that's what a type 2 region is. We're going from function to function in the positive x direction. So we'll always draw an arrow, sketch our region, as well as sketch an arrow in there so we know how to set up our integral. And I'm going to try to squeeze a similar statement to this one down here. So let's see if I can squeeze that right here. So here, x goes from function to function. Function to function. And y goes from constant to constant. And y goes from constant to constant. So those are two different types of regions. All right, so I'll stop this video here, and then in the next video I'll actually introduce how we integrate, how we actually set up the integral over a type 1 region and how we set up the integral over a type 2 region.